In this video, we want to use the definite integral to derive the formula for the area of an ellipse. Now here we're looking at the form where the major axis is horizontal and it's on the x-axis, center at 0, 0. But the formula will apply to any ellipse as long as you know the value of A and the value of B for that particular equation. So what we're going to do is we're going to look at this area right here. If we can compute the area of this portion of the ellipse, because of the symmetry, we have 4 of those multiplied by 4, and we get the formula for the area. So what we're going to do is solve this given equation for y. First we'll solve it for y squared over b squared. And take that over to the other side. It'll be 1 minus x squared over a squared. Then this will be y squared here, or b squared, and let's get the common denominator here of a squared, and we'll write this as a squared minus x squared, and this will be a squared here. Okay, multiply here by a squared and a squared, so I get the same denominator, and then multiply through by b squared to get the y squared by itself, and this will be b squared here. And I'm only interested in the top portion of this ellipse here. So I'll take the positive square root of this, and this will be b squared. Let's bring the a squared out of there, put it over here. So we get b squared over a squared multiplied by a squared minus x squared. And here I took the square root of this. I'm going to take the square, this is still going to be y squared here. Y squared here. Now I'm going to take the square root, positive square root, because I only want the upper section of this. So square root of b squared over a squared is b over a. And I've got a squared minus x squared. So in this interval here, the rectangular section that I'm looking at would be like this. And of course the width would be dx. That's how I get the integral. And then this height would be the y minus 0. And this is the y. And then that's going to be integrated. This could be a0 here. It'll go from 0 to a. Over here is minus a. But that doesn't matter. Up here is the point 0b. Down here, over here is the point 0 minus b. But again, all we need is from 0 to a. So we take the integral from 0 to a. And this is going to be your integrand right here. And whatever we get is going to be multiplied by 4. So here's what we wind up with. The area then would be given by this integral from 0 to a, b over a multiplied by the square root of a squared minus x squared dx. That's going to be the area, like I said, of this section here in the first quadrant. Multiplied by 4, that gives me the total area. And this is going to involve a trig substitution. So x then will equal to one of your formulas for trig substitutions. X is equal to a sine of theta. So we're going to transform this integral into one involving the variable theta instead of the so-called u substitution. So then dx here will equal to the derivative of a sine, so this will be a cosine of theta, and then this will be d theta. So we want to transform this integral into one involving theta. We're also going to change the limits of integration here. So if we look at this part right here, that has an x. Obviously the dx is going to be replaced by this, so that's going to get rid of the dx. We need to find a substitution for this a squared minus x squared. So if I look at a squared minus x squared, square root of that, this is going to equal 2. So this will be a squared minus x squared, but x is a sine theta. So take the x and square it, will give me a squared. So this will be a squared sine squared of theta. So if we factor out the a squared here, that will leave me with a factor of 1 minus sine squared, and the square root of a squared is going to be a. And then the 1 minus sine squared, using your Pythagorean identity for sine squared plus cosine squared equal to 1. This is going to come out to cosine squared, but the square root of that is cosine theta. So we're only looking at angles that are acute here for this formula. So the square root of cosine squared would be cosine theta. We don't have to consider the absolute value. So we get this right here. And then we go over here. Still got the 4 here. And let's look at, now we're going to change the limits of integration. Remember, these are for x. X equals 0 to x equal a. Now we want theta. So when x is equal to 0, we had sine theta divided by a into 0 is 0. Sine theta is 0 then, or x is 0 then, so sine theta equals 0. That means theta is equal to 0. Now, what happens at a? If x is equal to a, we get a sine theta equal a. The a's divide out, and we get sine theta equal to 1. What angle has a sine of 1? And of course, here we're looking at radians here. That would be 90 degrees, but in radians, that would be pi over 2. There we have it. So those are going to be our new limits. And again, that's just replacing the x by 0 here in this equation, here. Solving for theta, I get 0. Replace the x by a. A's divide out, I get sine theta equal to 1. The solution to that equation in the appropriate interval is pi over 2. And then, of course, for this right here, we got a cosine theta. And for the dx, we got a cosine theta, d theta. And then, of course, I still have the b over a here. And we can cancel one of these a's. This a and this a, say, will cancel. I'll get 4. Limits haven't changed yet. Stay the same. 0, pi over 2. You got a times b, so there's the ab. That's going to be d theta. And this right here then is going to give me a cosine squared theta. Again, 1a canceled out, and I'm still left with ba or ab. And then I got cosine squared theta, d theta. Now it's just a matter of integrating this from 0 to pi over 2. Now we do have a formula for cosine squared theta. We can reduce the power here. And let me go ahead and do this. Since a and b are constant, I'll put them outside the integral. Let's put them out here, ab. So again, for cosine squared theta, we have a formula that says that's equal from trigonometry. That's the same thing as 1 plus cosine of 2 theta. And this is d theta. That's over 2. And we can do this now. We can divide this 2 with this 4. There's x constants. So this becomes a 1 here, and this becomes a 2 over here. Let's just replace those. So 4 divided by 2 is 2, so I've got this out here. So I'm left with the integrand of 1 plus cosine 2 theta. So let's just integrate that. The constant is still here, 2ab. And then we're integrating with respect to theta. So the integral of 1 with respect to theta is just going to be theta. The integral of cosine is sine, whatever the angle is. So it's just 2 theta. And because I have a 2 theta, derivative of 2 theta is 2. So I have to divide by 2. So that's the integral. And then this is evaluated from 0 to pi over 2. So we got 2 AB. So remember the way it works here, we evaluate at pi over 2, evaluate this expression at pi over 2, and then it's minus the value of this expression at 0. So theta is replaced by pi over 2. Replace this theta by pi over 2. The 2's cancel out, and that leaves me sine of pi over 2. But the sine of pi, 180, is 0. So that's 0 there. And then it's minus the value at 0. So theta is 0. This will be a 0 here. Then it's plus. Put a 0 here where the 2 theta is. It'll be the sine of 0 over 2, but the sine of 0 is 0. So all we really have then is pi over 2 times 2ab. So just multiply this out. That is 0 here. And then this is 0. So 2 times pi over 2 is pi. And of course, AB. So that's the area. Anytime you have an ellipse, no matter where the center is, whether it's at the origin or somewhere else, as long as you know the value of A and B, the values that will determine the vertices of the endpoints for the major and the minor axes, all you got to do is multiply those values, AB, together, multiplied by pi, and that's your area. And of course, this is going to be in square units. Whatever the units are going to be squared, because you're looking at area. So we used a trig substitution to come up with the formula. Of course, you can do the same thing with a circle. The area of a circle is pi r squared. You can set it up the same way and find the area of the portion in the first quadrant, looking at the one with the center at the origin, multiplied by 4, and you'll get the area for a circle, pi r squared. Thanks for watching. We'll see you next time.